Today we've got a nice integral. We've got the integral from 0 to 2 pi of the maximum of sine x and sine 2x. So the first step we need to do is figure out which one is greater at which point across the x-axis, whether it's sine x or sine 2x. So we can draw them quick and get an idea of what's going to be happening. Sine x will look something like this, and sine 2x will do that twice as quickly. So doing one full oscillation every pi radians. So here we've got 2 pi, and here we've got pi. We can see they're going to overlap at 0, at pi, at 2 pi, and at 2 points down here. So we need to find those 2 points. To do that then, we'll just set the two functions equal to each other. So we'll have that sine x equals to sine 2x. Now if we use the double angle formula on sine 2x, we get that that's 2 sine x multiplied by cos x. We can now bring everything to the right hand side and factorise. We'll have sine x multiplied by 2 cos x minus 1 is equal to 0. So this term gives us all of our multiples of pi, where n is an integer. And this term here is going to give us that cos x is equal to a half. This gives us then that x is an even multiple of pi, plus or minus 1/3. And in this case, because we're limited between 0 and 2 pi, what we want is that it's pi on 3 and 5 pi on 3. So we know all of our locations. This is pi on 3, and this here is 5 pi on 3. So what we want to do now is integrate both our functions, sine x and sine 2x, but over different limits. So we can see for this first section, we have the faster one is above. So we want to use sine 2x over here. In this middle section, we want to have sine x, and it's going to alternate every time we swap over. So sine 2x, and then again at the end, just sine x. So we can rewrite our integral in terms of these limits. So we want the integral of sine 2x between 0 and 1/3 of pi, and also the same integral, sine 2x, between pi and 5/3 of pi. Plus then the integral of just normal sine of x from pi on 3 to pi. And again the integral of just sine of x just at the end. So the 5/3 of pi and 2 pi. If we integrate these individually, the integral of sine of x, nice and simply, is cosine of x, the negative. And the integral of sine of 2x, very similar. We're going to have negative 1/2 of cos 2x. So plugging this all together then, our integral is going to be, this will give us negative 1/2 of cos 2x. So we'll factorise the half out the front. When we plug in pi on 3 to cos 2x, that's cos of 2 pi on 3. And the negative. We'll then add, because the negative, cos 0. For this term, so we've done that one, cross that off. For this term on the right, we're going to have exactly the same stuff, but now with 5 pi on 3 times by 2, so 10 pi on 3. And then add cos of 2 pi, 4 pi times 2. So that's all the stuff for the sine 2x. With the sine of just single x, we're going to have cos of pi, but the negative. And then subtract a negative, so a plus, of cos of pi on 3. And then same sort of stuff, we're going to subtract the cos of 2 pi. And then we're going to add the cos of 5 pi on 3. A lot of these end up being either 1 or negative 1. So we'll cross those off and replace it with that. The cos of 0, cos of 2 pi are all going to be 1. So here we've got a plus 1. This is another plus 1. So altogether a plus 2. And we'll just contract all of this line. Don't need that plus in there now. And for the terms that came from sine x, we have cos pi here. Cos pi is negative 1. So negative 1 is plus 1. And cos 2 pi is 1. so we've got -1. So these two terms cancel out with each other. So we'll get rid of both of those and contract again the rest of the line. And we'll actually move this bit up alongside the other section. Now then, all of these terms that are left over, well, the ones in terms of cos, not the two in the middle, are all going to be either positive or negative a half. So we'll plug these all in. We've got a half of cos of 2 pi on 3, which is negative a half. Negative makes a plus, so we've got a half in there, plus the 2 still. And then cos of 10 pi on 3, again, is minus a half. So negative makes a plus. Doing the second bracket, both of those end up being positive a half. So all together, that gives us just 1 at the end. If we then look at this bit, how many have we got? A half plus 2 plus a half, that makes 3. So we've got 3 halves plus 1. All together, we've got 5/2.